Good morning, student. Today we are going to start the second unit, that is Introduction to Instrument Characteristics. Before this, we have completed first unit. In first unit, we have studied what is measurement, what is measurand, what is standard, then primary, secondary measurement system, then applications of the measurement system, and generalized measurement system, input-output configuration of the instrument, illustrations of the various examples such as Borden pressure gauge, bellows, uh, spring balance, then pitot tube. Okay. Then we have studied the classification of the various instruments such as primary, secondary, and tertiary instruments. Okay, so we will start the second unit. In second unit, first introduction. Instrument performance is described by means of a quantitative qualities which are referred to as characteristics. Means whatever or whichever the instrument is there, every instrument shows certain uh, performance. Okay, and that performance is described in terms of quantitative qualities. What type of magnitude it is showing, what type of output it is showing in terms of quantities and qualities, which are referred to as characteristics. Okay, which are broken down into subcategories or sub areas such as static characteristics and dynamic characteristics. The static characteristics pertain to a system where the quantities to be measured are constant or which vary slowly with time. Means whatever the static characteristics we are going to study, that static characteristics is nothing but the instrument where the quantities to be measured. Means in instrument the quantities to be measured are constant. It may be a constant or vary very slowly with respect to time. Okay, and the performance criteria based on dynamic relation constitute a dynamic characteristics, or we can say that that will be very fast or very rapidly. Okay, these are nothing but the dynamic characteristics. When the instrument is required to measure a time varying process variable, one has to concern with dynamic characteristics which quantify the dynamic relationship between the instrument input and output. Means uh, when the instrument is required to measure a time varying process variable means what? That the instrument shows the the output very rapidly. Okay, for that purpose we have to uh, concern with the dynamic characteristics which quantify the dynamic relationship between input and output. Okay, means for a small input the instrument gives a um, rapidly output very rapid output. Okay, with respect to time. Okay, and that time varying process variable will be studied by using the dynamic characteristics. Okay, by defining the relationship between the input and output. Okay, means here we have studied two types, that is characteristics. What does it mean by characteristics? The characteristics is nothing but the performance described by the quantitative qualities of the instrument. Okay, and that the characteristics are again categorized into two sub areas, that is nothing but the dynamic and static. And static means what? The static means what? The instrument or the system which gives the quantitative measured are constant or vary very slowly. Okay, with time, vary very slowly with time. Okay, or on the other side, that is dynamic characteristics means what? When the instrument is required to measure a time varying process variables, with rapid output or rapid variations. Okay, that is nothing with time, that is nothing but the dynamic characteristics. Okay, then first we will study all the static characteristics, and then we will move toward the dynamic characteristics. So first, static characteristics, the measurement of applications in which the parameters of interest is more or less constant or vary very slowly with time. Okay, the measurement of applications means any parameter we are measuring. In that case, the parameter of interest is, or what we can say that the output of the instrument is more or less constant or very slowly or varies very slowly with the time, means that that instrument is showing the output very slowly. That characteristics is nothing but the static measurement. Okay, and a set of criteria that provides a meaningful description of a measurement under static condition. The set of criteria, under a particular set of criteria, that instrument provide a meaningful description of measurement under static condition, and that is nothing but the static characteristics. The main static characteristics may be summarized as follows. First, static characteristics is a range and span, accuracy, error and correction, calibration, hysteresis, drift, sensitivity, threshold and resolution, precision and repeatability, linearity. Okay, so these are the different 9 static characteristics we will have to study one by one. Okay, so I think all of you got what is static measurement and static characteristics. Static measurement means what? The instrument gives output uh, more or less constant or vary very slowly with time. That is nothing but the static measurement. Static measurement. Okay, and a set of criteria that provides meaningful description. Suppose the static a set of criteria which we will provide the meaningful description of measurement under static condition are called static characteristics. Okay, so first we will have to study the range, what is range and what is span. Okay, so basically, uh, range means what? Having certain interval. Uh, Before going to in text, we can understood the name itself, that range is nothing but the interval from this value to from start value and end value. Okay, so that range with having certain interval from 1 to 10, from 10 to 15 likewise. Okay, so that what is the range? The region between the limit within which an instrument is defined. The region between the limit within which an instrument is designed to operate for measuring, indicating or recording a physical quantity is called as range. Means uh, suppose there is an instrument and that instrument having reading from minus 10 to minus 10 degrees Celsius to 80 degrees Celsius. In the range, suppose any instrument having the lower limit of reading is minus 10 degrees Celsius to and upper limit is 80 degrees Celsius. Means what? That instrument can measure the reading in between minus 10 degrees Celsius to 80 up to 80 degrees Celsius. Okay, and that is nothing but the range that is explained here. The region between the limit within which an instrument is designed to operate for measuring, indicating or recording a physical quantity. Means what? If that instrument is measuring the reading from minus 10 degrees Celsius to 80 degrees Celsius, in that case, suppose we have given some unknown input to the instrument, in that case that instrument will measure the reading in between minus 10 degrees Celsius to 80 degrees Celsius, uh, as well as indicate on the display panel or record that reading in the instrument. Okay, so that is nothing but the range of the instrument. Range is expressed by stating the lower and upper values. Okay, that I have already told you, that range is express the values by stating the lower reading and upper values. Okay, lower value and upper value. The span represents the algebraic differences between the upper and lower range values of the instrument. Uh, I think the what is range, all of you understood. The next parameter, that is span. Span is what? The span represents the algebraic difference of what? Upper value and lower range, upper range and lower range values of the instrument. Okay, so here few examples are given. The range of pressure measurement, that is 5 bar to 100 bar. Then range of voltmeter, that is 0 volt to 75 volt. Okay, such as thermometer, that is minus 10 degrees Celsius to 80 degrees Celsius. Okay, so here that temperature measurement, pressure measurement and voltage measurement measuring instrument, which can be usable for the measurement of temperature from minus 10 degrees Celsius to 80 degrees Celsius. Then pressure measuring instrument used for the measurement of 5 bar to 100 bar, and voltmeter from 0 volt to 75 volt. Okay, so the upper lower value for the temperature measurement is minus 10 degrees Celsius and upper value is 80 degrees Celsius. Likewise, all the examples are given here. Okay, now we are interested to find out the span. Now span is what? Span is the algebraic difference between upper and lower values of the instrument. Upper and lower values of the instrument. Now in case of the temperature measurement, uh, that upper means what? 80 degrees Celsius, and lower means what? Minus 10 degrees Celsius. So algebraic difference will become 80 minus in bracket minus 10 means what? Span will become 90 degrees Celsius. Likewise, for range of pressure measurement, uh, for what we are calculating the span, that is 100 bar minus 5 bar means 95 bar. Then in case of the voltage, what will be the span? The span will be 75 volt minus 0 volt, it will be 75 volt. Okay, I think all of you got what is range and what is span, is it? Then next we will have to study, that is accuracy, error and correction. Okay, so accuracy is what? It is a conformity with or a closeness to an accepted standard values or true values. Okay, so what we can say that uh, we can say that here, what is accuracy? Accuracy is nothing but the conformity or closeness to the true value or standard value. Okay, so in instrument, whatever the values we have measured, that measured value, uh, which how much closer to the standard value, that is nothing but the accuracy. Okay, so suppose we are targeting the any point, and we have projected something over that targeted point. So in that case, what will be the deviation from the targeted point? uh, okay, that deviation is nothing which will represent the accuracy. Okay, so second is error, static or absolute. There are two types of error. What that error is, static or it may be absolute. The difference between the measured value and the true value, that measured value is represented by v suffix m, and the true value is represented by v suffix t of the quantity, represent static error or absolute error of measurement. Okay, static error or absolute error of measurement. Okay, which is represented by e suffix s, which is represented by e suffix s. And that static error is nothing but the difference of what? Measured value and true value. Then next parameter we will have to study, that is correction. Okay, the difference between the true values and measured value. Okay, true value and measured value of the quantity represent static error. Is it? So it is nothing but just there will be algebraic difference of uh, measured value and true value. It will be error, and correction is what? Correction is what? True value minus difference of true value and that is measured value. Is it? Means only that there will be a shifting of parameter. Okay. So in case of error, the measured value minus true value, and in case of correction, that is true value minus measured value. Okay. So that es represent the correction, minus es represent the correction required in the measurement. Okay, and error is represented by the difference of measured value and true value. Okay, the accuracy may be expressed as point accuracy, percent of true value, or relative statement errors, or percent errors. Okay, so the accuracy may be expressed as point accuracy, the percent of true value, or a relative static error. The percent error equal to measured value minus true value upon true value multiplied by 100. Okay, measured value minus true value upon true value into 100. Uh, Here you have to just keep that formula in mind. For the simple numericals will be asked in that case. Okay, the percentage of full scale deflection. uh, in that case, the percentage error will be measured value minus true value upon maximum scale deflection. That maximum scale deflection means what? Maximum scale deflection is nothing but from 0 or for lower range to upper range. What will be the maximum deflection of the pointer in the dial indicator? Okay, dial of the measuring instrument. Okay, means maximum scale deflection means what? From lower range to upper range, what is the maximum deflection of pointer in the instrument? That is nothing but the maximum scale deflection. Okay, and full scale deflection is error is nothing but the measured value minus true value upon maximum scale deflection into 100. Okay, so here we have studied the accuracy. What is accuracy? Accuracy is the conformity with or clearance, or what we can say that the closeness to a closeness of measured value with true value. That is nothing but the accuracy. Is it? The next parameter is calibration. Okay, so what is calibration? That I have explained the first unit also. So before going to textual text material given in the slide, we just explain with the help of one diagram. Okay, we will calibrate the spring balance. Okay, so you have observed the spring balance. Okay, so this is the spring balance, or we may call it as the spring inside that spring balance. Okay, this is the pan of the spring balance. Okay, now, and here is the pointer which we will observe. Pointer, and here the measuring scale is given. Okay, on that measuring scale only the markings are there. Is it? The basic principle of spring balance is that whatever the weight we will place in the pan, there will be some deformation, or what we can elongation of the spring will take place, and as the elongation takes place, this pointer will move in the downward direction. Is it? Means on the scale here will be 0, then somewhat 5 and 10 kg. Likewise, I have just taken the for the explaining point of view. Here the pointers will start from 0 to 10 kg. Okay, so whatever the weight we will place in the pan, what will happen? This pointer will become means, or the spring will get elongated, and the pointer will be travel along the scale, and where that point will indicated on the marking, that will the indication of the measure of the unknown weight placed in the pan. Okay, but we are studying the calibration. Okay, means that instrument is not working properly and we will have to calibrate that instrument. So first we will forget about that readings. Okay, means whatever the marking given on that measuring scale, that will be remain same, but magnitude means values corresponding to that marking that we have removed. Okay, so we are interested to calibrate that spring balance. So in that case what we will do, we will place the weight of 1 kg, then 2 kg, 3 kg. We will place the weight of 1 kg, 2 kg, 3 kg, 5 kg. Likewise, we will place the weight on the in the pan. Okay. Now in that case, when we will place certain weight of known or standard weight of 1 kg in the pan. Okay, what will happen, this pointer will move in the downward direction. Okay, so that pointer will represent certain or match with the marking in the scale. Okay, so we will mark it as 1. Then when we will put the 2 kg weight, okay, by removing the first 1 kg weight, we will place the 2 kg standard weight in the pan. What will happen, again the pointer will move in the downward direction and it will match with the marking provided with the scale, that will mark as a 2. Okay, then we have removed the 2 kg weight and placed the 3 kg weight or standard weight into the pan. Then what will happen, again the pointer will move in the downward direction of this and match with the marking of scale. Okay, so that will be marked as a 3. Likewise, we have or we will place the standard weights in the pan and study the intersecting point of the pointer and the scale reading. Okay, so that we will means by using that known weights, we will mark each and every point on the measuring scale, so that whatever the errors occur in the before calibration, okay, that will be eliminated by using this process. Okay, and we will get the exact reading for the unknown weight. Now once we have got the scale from 1 to 10 magnitude uh, for the measurement of masses, okay, 1 kg to 10 kg. Now whatever the unknown quantity of weight we will place in between 1 to 10 kg, that will indicate in between. So suppose that pointer will match with the marking of 2 means in between 2 and 3, so that will be the indication of weight, that is unknown weight will be 2.5 kg. Understood? Are you getting it everyone? मीन्स यहाँ पे क्या बोल सकते हैं अपन, सो जो भी अपन ने मार्किंग थी स्केल के ऊपर, उसके करस्पॉन्डिंग क्या किया है, नॉन वेट से उस स्केल को कैलिब्रेट किया है, बराबर है. अब क्या करने वाले हैं कि अननोन वेट अपने को मेजर करना है विद द हेल्प ऑफ दैट मेजरिंग स्केल. ओके, सो व्हाट वी विल डू, we will place the weight in the pan and for that unknown weight there will be again deflection of pointer along the scale. Now that pointer of the spring balance will match with the marking provided on the measuring scale. Okay, so that point will be an indication of the unknown weight. Okay, and that pointer will be intersecting the marking on the scale in between 2 to 3 or exactly 2 or 3 or in between 3 to 4. Okay, likewise, so that will be the measure of unknown weight. Okay, means what we have just done, we have compared the compared the known quantity with the unknown quantity. Okay, we have compared the unknown quantity of mass with the known quantity by calibrating the instrument. Okay, so I think all of you got the these iterations we have performed in the spring balance. Okay, so that is nothing but the calibration. Now here the magnitude of error and consequently the correction to be applied is determined by making a periodic comparison of instrument with a standard, which is known as constant. Okay, and the entire procedure laid down for making, adjusting or checking a scale so that the reading of the instrument or measurement system conform to an accepted standard is called as calibration. Okay, so whatever the textual matter given in the slide, that I have explained with the help of iteration that we have shown in the next slide. Okay, so that is nothing but the calibration. Similarly, for pressure measurement also is calibrated. Similarly, the voltage measuring instruments are also calibrated. Okay, so each and every instruments are calibrated in this way. Okay, so that is nothing but the calibrations. Okay, today we have studied the three characteristics such as range and span, then next accuracy, error and correction, third that is calibrations. Okay, so whatever the other characteristics of the instrument that we will study in the next unit, such as the hysteresis, drift, sensitivity, threshold and resolution, that we will cover in the next lecture. So we will stop over here. Thank you.